Today we're going to take a look at our outer planets and go ahead and fill in the second half of our flip book. So just a reminder when we're looking at our planets that here they are in order, and this is often how you see them in pictures of the solar system. But in reality, they're not usually lined up all neatly like this all in a row. That's very rare. Your flip book is probably a little bit more accurate in having the planets in different spots along their orbit. And also, the inner planets are super close to the Earth compared to the outer planets. So if you remember the model that we made out in the hallway and where you were standing in that with your sign, these are our inner planets, and they're so tiny you can't really read them clearly here in this image, but they're very close to the sun compared to the outer planets. Our gas giants are much farther away. There's a lot more distance here. So here's Jupiter, and then Saturn, Uranus, and Neptune all the way out here. In comparison then, this is just a fun image I found that shows what the sun would look like from each of these planets. So if you happen to be on the surface of these planets, which of course we can't be, no human has been to anywhere except for the moon. But anyway, if you were to land on the surface of these planets and look up at the sky, this gives you an idea of how big the sun would look. So all of these planets are really far away from the sun. And so that means that they're going to have very little heat from the sun. And so all the temperatures we're going to be looking at today for these planets are in the negative. They're temperatures that are well below zero. These planets are frozen. So let's take a look at our first planet, the planet of Jupiter, and that would be our fifth planet from the sun. Temperatures on Jupiter, as I said, are negative. So this little minus sign out here in front means a temperature below zero, negative 234 degrees Fahrenheit. For Jupiter, it just has 4 rings, and they're relatively thin. You usually need a telescope to actually be able to see that they're there. The moons on Jupiter, though, can be seen. If you remember, we mentioned that Galileo, with his telescope, was actually able to discover some of those first moons of Jupiter. Some of them are pretty large. There are a lot of moons, though. Because the planet is so big, it has a strong gravitational pull, so it has a tendency to pull objects towards it. And so as we learn more about the planet, we think it may be pulling new objects toward it, and so it literally adds new moons, but also the fact that we are getting better and better telescopes, so we're better able to see smaller and smaller objects. So this image shows some of those moons. It was actually taken in 2010, so it doesn't have all of the 79 moons, but you can see that it's got a lot of stuff going on around its surface. Of course, we know that Jupiter does not have a solid surface since it's a gas giant. This image is actually from a satellite probe called Juno, and it's just a couple years old, and it shows us a close-up of the surface of Jupiter, and you can see that it's got these amazing clouds and gases that are just swirling around on its surface. Its diameter is an impressive 86,881 miles across. And again, remember, diameter is like the distance across the middle of the planet, 86,881 miles. So compared to all of our other planets, that does make Jupiter the largest planet out of all of them. However, even though it is the largest planet and it's really impressive compared to Earth, keep in mind that Jupiter is still much smaller than our sun. 98% of the mass of our solar system comes from our sun. So when you're comparing Jupiter to the sun, it is still kind of puny looking. And there is Earth, even more puny. The number of space missions we've sent to Jupiter is 8, and some of those have been ones that have just flown by, and then others have been able to get up closer and actually orbit the surface. The most recent one is Juno, which took 4 years to get there, and is sending back some amazing pictures, like I showed you earlier, of the surface of Jupiter. Because Jupiter is made out of gases, even though it's really big, it's surprisingly pretty fast in how quickly it's spinning. So the rotation of Jupiter is only 10 hours. That means that its day is only 10 hours long. On the other hand, because it's so far away from the sun, it takes 12 years to orbit the sun or revolve around the sun. So if we take a look at Jupiter, it would take 12 Earth years for it to get all the way around the sun and back to where it started. And that's part of why we keep finding new moons on Jupiter, is the fact that since it takes 12 years for it to orbit, we can't see all the parts of Jupiter, and it takes us 12 years to fully see it orbiting around the sun from here on Earth. So we keep discovering new things about it as it moves and changes its position. And of course, the last one is we know that this one is an outer planet, which is what all of the planets are that we're looking at today. That brings us to our next planet. The sixth planet from the sun is, of course, Saturn. And Saturn, being even further away from the sun, is even colder than Jupiter. So the temperature on Saturn is a negative 288 degrees Fahrenheit. There's a close-up of its surface from one of the space probes, and it actually has the little white flecks there are a big icy storm that went on for 12 years, negative 288 degrees Fahrenheit. Saturn, of course, is most famous for its rings, and it's pretty hard to count them because there are so many of them. So we're just going to call it over 1,000 rings and leave it at that. And you can see this is a computer-generated image that shows you some of those rings, and they really are different colors to them depending on the materials in them. This is an actual real Hubble telescope space image where they zoomed in on the rings, and so they do look kind of fuzzy here. That's all little ice particles that show you a close-up of what they look like. For moons, Saturn actually has more moons than Jupiter. It actually has 82 moons, and that actually was a couple of years ago they found that out. When it continued to revolve around the sun, it got to a point where we could see the other part of it, and we were able to discover a whole bunch of moons that we hadn't seen before. And so it had something in the 60s, and now they discovered literally like 20 more moons all at once. And so those moons actually don't all have names to them yet. This is just kind of some of the bigger main moons of Saturn. However, it has 82 altogether. Probably one of the most famous ones here is this one, Titan, which is actually really impressively large. And they actually sent a space probe that not only explored Saturn, but also explored its moon Titan. And so there's some pretty cool pictures, and we actually have been studying and been very interested in that moon for a while. Of course, it does not have a solid surface. In 2017, the space probe Cassini was sent to Saturn, and it actually was intentionally crashed into the planet's atmosphere. So they wanted to get a really nice close-up photo of Saturn, so they sacrificed the space probe and intentionally sent it down to crash into Saturn and down into its clouds and atmosphere. And it was destroyed by, of course, the really strong winds. But this is one of the last images that it sent back, so you can see the clouds that are very thick and dense and kind of swirling that are covering the surface. The diameter of Saturn is 72,367 miles, so pretty large, but in comparison to Jupiter, it is obviously significantly smaller than that. If we compare it to the rest of our planets, though, here is Saturn compared to the rest of them, and you can see that it's quite a big deal, quite large compared to Uranus and Neptune, and much bigger than Earth. We've sent a total of 4 space missions to Saturn. As I mentioned, the most recent one, Cassini, got some really cool up-close photos of the rings of it as well as its moon Titan before crashing into the planet. Similar to Jupiter, it rotates pretty quickly because it's a gases, so it actually revolves in, it only takes 10 hours for it to make one full rotation. But since it's farther away from the sun than Jupiter, it takes 29 years for it to get the whole way around the sun and back. So one of its years is 29 Earth years. And as I mentioned, that means that for us to study Saturn, it takes 29 years for us here on Earth to see the full orbit of Saturn. And so that's why we can't always see all the parts of it, and we're kind of learning new things about it every time it changes position in the sky. And of course, we know that Saturn is an outer planet. That brings us to our next planet, Uranus. It can be pronounced Uranus, or it can also be pronounced Uranus. That is our 7th planet from the sun. And of course, our temperatures are getting even colder as we get farther away. So Uranus is actually negative 371 degrees Fahrenheit. Brr. Rings for Uranus, it has 13 of them. This is a blurry image from the Hubble telescope that shows you some of them. And again, remember that it's really far away, so it's hard for us to get precise pictures of something that is this far away from us. This is a close-up, though, that shows you those rings a little bit better. And again, they're just made out of like icy, dusty particles. Uranus has a total of 27 moons. A lot of them are pretty small. So here are the 5 largest ones that we can see. And of course, Uranus does not have a solid surface. Officially, it's made out of gases, though the gases are pretty tightly packed together because it is so incredibly cold. The diameter of Uranus is 31,518 miles, 31,518 miles. So it is just a little bit larger than Neptune, but pretty similar in size to it. And again, if you compare Uranus to Earth, it's definitely larger. We have actually only had one space mission to Uranus where we've actually been able to send a probe, and that was all the way back in 1986. The space probe Voyager 2 flew past Uranus, and in 6 hours, that's all the time that it got to take photos of it as it flew past it, it took some close-up pictures of the surface, and that's the only up-close photos that we have of it. Remember that Uranus does rotate on its side, so it's tilted differently than the rest of the planets, and it does take 17 hours for it to make one complete rotation. Its year is 84 Earth years. For it to make one full revolution around the sun, or one full orbit, it takes 84 years. And one of the unique things about Uranus, because it rotates on its side like that, one of the poles will get way more light than the other one. The other pole is really, 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 really cold because it's not getting any direct light for a very long time in its 84-year orbit. And of course, we know that it is also an outer planet. Our last planet is the planet Neptune, which is 8th from the sun. Its temperature on Neptune is negative 353 degrees Fahrenheit. So it's just a little bit warmer actually than Uranus because it doesn't have that weird issue with it being on its side and having one pole that's really, really cold. The rings on Neptune, if you look at how far away it is and how far out it is, the rings on Neptune are 5 total. And again, they're kind of in spread out sections here. So there's like 3 of them that are kind of concentrated together, and then 2 more outer ones. It has a total of 14 moons that we know of, and some of those are actually in the rings, and then some of them are farther out. Of course, we know it does not have a solid surface to it. Here is a picture from the Hubble Space Telescope, and again, it's going to be blurry because it's really far away, but it does show one of the clouds that has a dark storm in it. The diameter of Uranus is 30,599 miles, so it is just a little bit larger than Neptune. I said that backwards. The diameter of Neptune is 30,599 miles, so it is a little bit smaller than Uranus, sorry. Space missions to Neptune is one of them, and again, that's the same one that went to Uranus. It's the Voyager 2. It does take 18 hours for Neptune to make one full rotation, and it takes, get this, 164 years for it to make its way the whole way around the sun. As I said, it is really, really far away from the sun. I'm trying to go back here so you can see the picture that shows how far it is. So here's the sun, and there's Uranus in comparison, and Neptune is way, 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 way out there. Sorry. Okay. And of course, we know that it is an outer planet.